Okay, let's talk about composition of trigonometric functions. In Algebra 1, we learned about this. If f of x and f inverse x are inverse function to each other by switching x and y, these two rules works. F of f inverse, this is composition function. F of f inverse x is equal to x, which is same as this x. And f inverse of f of x, this is also composite function in other way, is also equal to x, which is same as the original x. So in trigonometric functions, we can use these rules, but there is restriction. To use first composition rule, let's say this is first composition rule, second one is second composition rule. To use first composition rule, x should satisfy domain of inverse function. To use second rule, x should satisfy range of inverse function. Let's try some example questions. Question A. Tangent, arctangent, -5. So this is like first format. F of f inverse -5, right? Because arctangent is same as tangent inverse. So if that number, which is x, satisfy domain of inverse tangent, the answer is -5. What was domain of inverse tangent? Domain of inverse tangent is all real numbers between -infinity and +infinity. -5 is real number, right? So the answer is -5. Easy, right? Question B, arc sine, which is sine inverse, sine 5 pi over 3. Okay, this is second case. Second composition rule, because inverse function came first. F inverse of f of x equals x only when x satisfies the range of inverse sine. But what is range of inverse sine? Range of inverse sine is between -pi over 2 and pi over 2. Between -pi over 2, pi over 2. So x, if x is between -pi over 2 and pi over 2, the answer is x, right? What's x? 5 pi over 3. That's out of the range. So answer is not equal to 5 pi over 3, which means we cannot use composition rule. So in this case, you just find the value of sine 5 pi over 3. This is straightforward, not inverse function. So it's like sine inverse. What is sine 5 pi over 3? Sine 5 pi over 3 is negative square root of 3, right? Negative square root of 3. And set up k, because we are solving inverse question, switch x and y. Switch x and y to go back to the original sine function. So sine k, angle k is negative root 3 over 2. All right. Because we are solving sine inverse question, we can use either Q1 or Q4. Do not use Q2 and Q3. And sine k, sine angle k is negative, so k is in fourth quadrant. Because in first quadrant, sine is positive. So we can set up k in Q4. The value sine k is negative root 3 over 2, because sine is opposite over hypotenuse. Length of the other leg should be 1, right? So k is the angle which is located opposite side of ratio square root of 3. So k is root 2, 60 degree in negative way, right? Negative 60 degree or negative pi over 3. All right. Question C. Cosine inverse pi. Okay, this is like first case. So f of f inverse x equals x only when x satisfies domain of inverse cosine. What is domain of inverse cosine? Domain of inverse cosine is between -1 and 1 inclusive, right? In this case, answer is just x. But pi is like 3.14, right? Which is greater than 1. So out of the range, out of the domain. So answer is not equal to pi. We can't use composition rule. So we should find the value of this one first. Cosine inverse pi, right? So set up k for inverse expression. Cosine inverse pi equals k. K should be between 0 and pi because range of cosine inverse is between 0 and pi. Switch x and y. Cosine k is equal to pi. But the maximum value of cosine is 1. Minimum is -1, right? You can't make pi. So no angle k value can satisfy this equation. So what is the answer? No answer, no solution. No solution. All right. Let's try another type of composition question. In these two questions, we can't use composition rule. F of f inverse x equals x or f inverse of f of x equals x. We can't use these two. Why not? Because given functions are different. It's not tangent inverse, right? It's not cosine inverse. Functions are different. So in this case, we should use k rule. This is arc cosine, which is cosine inverse. Set up k, all right? And we are solving tangent k, okay? Then let's simplify this expression first. We already substitute k for arc cosine 2/3, cosine inverse 2/3 because arc cosine is same as cosine inverse equals k, switch x and y, so cosine k equals 2/3. All right, I'm going to use right triangle in the right quadrant because k is used as y value of inverse cosine. So k should satisfy range of inverse cosine, which is between 0 and pi. This way, do not use these two quadrants. And cosine is positive in first quadrant, not second quadrant. So you can make right triangle in the first quadrant. So angle k is in first quadrant. Cosine is 2/3, adjacent over hypotenuse. So by using Pythagorean theorem, we can find the other leg, right? Pythagorean theorem, square root of 3 squared minus 2 squared, which is 9 minus 4, square root of 5. And then we can find the answer. Tangent k, we already substitute k for this whole thing, right? So it's like finding tangent k. So what is tangent k? Opposite over adjacent, which is √5/2. That's the answer. All right, question B. Cosine I cosine -3/5. This is inverse expression, so use k. Sine inverse -3/5 is equal to k. Switch x and y. Sine k equals -3/5. I'm gonna make right triangle in fourth quadrant because range of sine inverse is between -pi/2 and pi/2 this way, so we can't use these two quadrant. But sine k is negative, so k should be in fourth quadrant, not first quadrant, right? So reject first quadrant. In k is an angle in the fourth quadrant, and sine value is opposite over hypotenuse, -3/5. And this is 3, 4, 5 right triangle, and we can find cosine k because we already substitute k for this whole entire sine inverse expression. So it's like finding cosine k. What's cosine k? Angle is here, right? Cosine is adjacent over hypotenuse. The answer is 4/5. All right. Okay, let's try a little bit different types of question. Write each of the following as an algebraic expression in terms of x. Okay. We need to change the given trigonometric expression to another expression in terms of x only. So we are not going to use sine, cosine, tangent. All right, the given function is sine arc cosine 3x if x is between 0 and 1/3. All right. Yeah, let's talk about 3x. If x is between 0 and 1/3, let's multiply 3 on each side. 3x is between 0 and 1 because 0 times 3 is 0, x times 3 is 3x, 1/3 times 3 is 1. We found the range of, interval of x, interval of 3x, which is between 0 and 1. And then, because this expression is inverse expression, set up k. And we are finding sine k. Arc cosine, which is cosine inverse 3x equals k. Switch x and y. So cosine k is 3x. And we know that 3x is between 0 and 1, right? So cosine k is positive or 0. Let's use first quadrant. Because in second quadrant, cosine is negative. But we know that cosine k is positive. Yeah, cosine k is 3x, but we can use ratio from 3x, which is 3x over 1. So if angle k is here, the ratio of each side is adjacent over hypotenuse because cosine k is 3x over 1. Then what's the other leg? Use Pythagorean theorem. Square root of 1 squared minus 3x squared, which is square root of 1 minus 9x squared. All right, then we are finding sine k because we already substituted k for this expression. We are finding sine k. What's sine k? K is here, right? So sine k is opposite over hypotenuse. Square root of 1 minus 9x squared.